This is part 2 of the notes on Unit 2. Here we are talking about your requirements for having a computer forensics workstation. A computer forensics workstation basic requirements are having Windows operating system. Windows 7 can be perfect. Windows 8 as well. You will need to have a write blocker device in order to prevent any writing to any piece of evidence that you will be working on. A computer forensic acquisition tool I will recommend later on in the units. A tool that is free. We will be using FTK Imager. This is a tool that is free and you can download it. We also need on our forensic workstation analysis tool. I don't think you will be able to get FTK or InCase. Those are expensive to purchase, but there is a tool that is coming with the textbook on the CD called ProDiscover, and we will need that. I will be also showing you during the coming units the other tools, those FTK and InCase, at least how to use them for certain functions that we're going to be needing, just for you to know what are these and how they work. Of course, you need a target drive to receive the source or the suspect disk data. Usually we try not to mingle the data that we are investigating with our own data, so it's perfect to have either a separate drive or a separate partition. For the requirement of this class, you don't need to repartition your computer right now. We'll use your computer as it is. Most of the images I will be providing for you, so you don't need to purchase a write blocker. And the other tools that we will be needing, make my best that you will be using and downloading free, good tools that we are using in this field. Other things that a forensics tool have usually is, of course, an interface, network interface card, a NIC, sometimes an extra one, extra USB ports, FireWire ports to make it easier, SCSI cards, disk editor tool, text editor tool, and of course a graphic viewer programs. You probably have at least some of those on your computer, and this is what we'll be using for this class. Again, when it comes to conducting the investigation itself, you need to look at your plan that we talked about before, and you need to gather the resources that you need. Some items that you will be needing, the original storage media, let's say the hard drive or let's say the flash drive, the evidence custody form, that's the form that we mentioned before, and it's very important to know in order to know what happened to that evidence through time. The container for storing the media, the Bitstream Imaging tool, and I'll be talking about that in a second in the next slide. Your forensic workstation that we mentioned also in the last slide, and a securable evidence locker, a cabinet or a safe. That's in your if you are working in an environment like a corporate or of course in the law enforcement. What is this Bitstream Imaging tool that I mentioned? In order to conduct your investigation, as we said, one of the golden rules is we don't make any modification to the original media, to the original evidence. What we need to do is to create a copy of that media, and we do that with a tool that we call it the Bitstream Imaging tool. We can create either a Bitstream copy or a Bitstream image. By copy, I mean a bit by bit copy of the original storage, exact copy of the original disk, meaning we are copying everything on that disk as it is, not only the files that are existing on that media, but also all the disk space, which means that will include anything that was deleted or any unallocated space on that disk. So we are creating an exact copy of that piece of evidence that we got. We get one hard drive, let's say, and when we do a Bitstream copy, we get another hard drive that is similar to the drive that we have, and it will contain the exact same things that the original one had. The other way to do this is, instead of copying from one drive to another drive, is to create a file, and that file we call it an image. So we're creating a bitstream image, which is a file that contains the bitstream copy of all the data on the disk or the partition. Again, by all data, what we mean is not only the files and programs and everything that is appearing there, not deleted, but also all the space on that disk, which include all the unallocated space on the disk, meaning anything that was deleted and still not overwritten will be able to recover. This bitstream image, also known as the forensic copy, forensic image. As we said a second ago, any deleted files on a hard drive or flash drive, any disk, will stay there, or they're not deleted. They will stay there until they are overwritten, until a new data is written to the same exact space where the old data is written to, and at that point we cannot recover it. But if it's still there and it was not overwritten, then we can recover it. So one of the jobs that we're doing here in forensics is to recover that data from either deleted files or parts of files, fragments, or if it's a complete file that's still there, not deleted, and it includes the evidence that we are needing. Don't forget that, because a lot of times a certain evidence, certain data gonna be under our noses there. It's not deleted, not hidden, not anything. It's just there. So one of the things that you will be doing is to look at the data that exists first, and then to start looking for deleted files or fragments of files. Now let me make a huge jump and talk about when you finish your case. In order to complete it, you need, of course, to produce a final report. Your report is actually the product of your work. This is what you're going to be giving back to whoever asked you to conduct this investigation. In this report, you will state what you did find and what you did not find. Most tools that we are using for analysis will be capable of creating that report. Make sure that your findings are repeatable. This is another golden rule of computer forensics. Your findings have to be repeatable, meaning if somebody else is doing the same things that you do, they will get the same results. Also, you can test that by choosing a different tool to do the same exact function, and also you will have the same results. A valuable advice would be that you are documenting everything that you are doing in the case all the way. It is very, very important to make sure that you can explain everything that you did. And the best way to do that is by documenting all the steps that you are doing in details, actually, in order to be able to answer any questions about what you did and why you did that. Your report should show conclusive evidence. The suspect did or did not commit a crime or violate a company policy. Well, those are very strong words here, but your investigation should at least say, I did find or did not find an evidence to prove that a suspect did commit or did not commit the crime that he's accused with, or the company policy violation. After completing your case, a good practice is to critique the case that you just worked on, to ask yourself questions like, how could you improve your performance in the case? Did you expect the results that you found? Did the case develop in ways you did not expect? Especially pay attention to the documentation that you did. Was this documentation as thorough as it could have been? And what feedback has been received from the requesting source? Another good practice is, before giving all the results, is also to give the case to a colleague who will look at your work and also critique the case, and probably be able to suggest something to improve or to do it differently, maybe to do things in a different, easier way, methods that can save time, things like that. Okay, we've been talking a lot, and it's time for some action now. Part 3 of the presentation is actually a video that I will show you how to use FTK Imager. This will be probably your first forensic tool that will be an integral and very important part of your tool set. The textbook also have an example, a similar exercise with the tool ProDiscover. This tool comes on the CD that comes with your textbook. You can go ahead and try creating an image of a USB drive using that tool. I recommend using, if you have a USB drive that is no bigger than 1 gig, in order not to take a long time doing it, just go ahead and get your hands dirty with forensics. Good luck.